All right, key ideas from this section. How did Mendeleev arrange the elements in his periodic table? How are elements arranged in the modern periodic table? So Mendeleev, he was not the first person to make a periodic table. There were several versions that had been made before, but he was the first person to develop this way of arranging elements that resulted in a lot of patterns. And so those patterns helped us to predict things. So in Mendeleev's periodic table, he arranged elements in rows by increasing atomic mass. Because he arranged the elements in rows by increasing atomic mass, there were some patterns that he began to see. And because of those patterns, he was able to understand that there were elements that were missing that hadn't been discovered yet. And so Mendeleev left spaces in his table to make that pattern fit. And so one of these that he was able to predict was germanium. So he used the spaces in the table and looked at the elements that were around those empty spaces to predict the existence and properties of elements that had not been discovered yet. So one of those, again, was germanium. And based on what germanium was around, and so he left the space between silicon and tin in between those two elements, and he predicted based on what it was between, that it was between silicon and tin. He was able to predict a lot of things about it. And so his prediction showed that this mysterious element that hadn't been discovered yet would have an atomic mass of 70, a density of 5.5. It should be like a dark gray metal, and it should have a high melting point. So later on, and this happened in Mendeleev's lifetime, this element was discovered, and it was found out that it had a atomic mass of 72.6, so he's very close to that. It had a density of 5.3, so his prediction was very close. It was a gray metalloid, pretty close on that, and it had a high melting point. And so Mendeleev was so sure of his prediction that when this element was actually discovered, he tried to take credit for it. So even though he wasn't the one that found it in nature, he didn't collect the sample or anything like that. He said, I predicted this element, and so I should get credit for discovering this element. Now, Mendeleev, using increasing atomic mass, there were a few elements that did not fit the pattern. So now we arrange the periodic table by increasing atomic number. And it doesn't change the order very much from what Mendeleev had, except for indium, I think, is pretty much the only one whose atomic mass is not in order. But arranging by atomic number, now we have a more close arrangement based on chemical properties. So when elements are arranged by atomic number, elements have similar properties at regular intervals, meaning every 8 elements will start to repeat chemical properties over. And so we can then, based on where something is on the periodic table, we can predict what it will bond with, if it will bond violently or not, and lots of other different things about the element. So as scientists have learned more about the structure of the atom, they improved upon Mendeleev's table. And so again, Mendeleev is kind of credited with the first periodic table, but it's really just the first periodic table that is revised into what we use today. When we arrange the periodic table by atomic number, the number of protons, so all the elements go by increasing number of protons, rather than by atomic mass, This fixed the discrepancies or the mistakes in the pattern that Mendeleev had. And so from this, we have developed what is called periodic law. And periodic law is the law that states the regular repeating chemical and physical properties of elements change periodically with the atomic numbers of the elements. If something changes periodically, it means it changes at a regular interval. So a newspaper is a periodical. It comes out once a week. Magazines can be considered periodicals. Some of them come out twice a month, once a month. There are lots of things that occur in regular intervals, and periodic table is one of those. So we can say that when we arrange by increasing amount of protons, then the properties will repeat in certain intervals, and so they change periodically. So this is the periodic table. We should be getting familiar with the periodic table because we use it almost every day in class. But now we're looking specifically at what it tells us. First off, we need to know that the columns are called groups. And so we have group 1, 2, 3. They go in order. And so we have all the way up to 18 groups. So there's 18 columns. We also need to know that the rows, so going across, are called periods. And there are 1, 2, 3, 4, 5, 6, 7 periods. Now these 2 rows down here actually fit in period 6 and period 7. But the periodic table will be super wide if we left it the way that it should be. So generally they cut that section out and put it at the bottom. But just know that this actually is row 6 and row 7. So this periodic table has color coding, and the color codes show us what type of element that all these different things are. And so it says that yellow is hydrogen. Hydrogen is in its own group because it kind of has its own sort of properties. And then the orange are semiconductors. We also can call these metalloids. That's another word for those. And it just means that these are kind of like the middle of the road elements that can behave like metals or like nonmetals. Lilac, light purple, are the alkali metals. The bluish color are alkaline earth metals. All of these red, and I always call this the bridge because it kind of looks like a bridge between these 2 high sections. So everything in the bridge are transition metals. These light blue are called other metals, and they just they don't fit necessarily with the transitions, but they also don't fit with these other groups over here either. Brown are halogens, purple, noble gases, and then these green are the nonmetals. Again, they are called other nonmetals because they don't fit with these 2 groups. So when we look at the periodic table, everything on the left are metals, and elements become less metallic as you go across toward the right. So you start out and you've got metals on the left, and every time you move over a space toward the right, it becomes less and less like a metal. So less metallic across a period, and again, a period is a horizontal row going across. Elements in a group have similar properties, and so a group is a column. And so it's a vertical column of elements, and we need to know that everything in that group shares certain similar chemical properties. Again, things in a group are not exactly alike, but they are similar, kind of like your group of friends. You're not all going to be exactly alike, but you share similar interests or ideals or whatever it is that makes you be friends.